All right, let's get this done. Let's do this. What I want to do is just bear with me. I got you. I want to look at the whole circuit design, and also we'll tackle the ladder logic. So we're going to take a look at finding which components we need from the report. And then from there, what we're going to do is put them onto Automation Studio, just the basics, just the most basic control, the most basic stuff, just the fundamental equipment. And then once we get it kind of working with the basics, like cylinder goes out, cylinder comes back, cylinder goes out, cylinder goes back, we're done. Then we can add more complication. We can add the timers. We can add the safety control. We can think about, hey, what kind of, maybe we might want to change the limit switches. Maybe we might want to change the DCVs. Maybe we want to tweak things a little bit. And then you can think about more things like, hey, should I put in like metering on any of the cylinders? Does that come in the description? Or maybe should we maybe think about putting cushioning? And then we can think about adding more ladder logic and more design, like putting the timers in. And also just like safety stuff and shutdown sequences, and then run it and dial it in, get it bigger, get it just better. Don't worry about the big and better. Let's just start and focus on the simple stuff and the most basic operation, and then we'll dial it up. So let's take a look at the project description. We're going to focus on just the control stuff, like the operational parameters. We've already gone through this, already done the preliminary design. You already kind of have an idea of what to do. We're going to actually try and figure out how to put this and tune it well on Automation Studio. So all we need is the basics. So let's just go over this. Okay, so we know that we've been commissioned to build this thing. The one thing is that I wanted to highlight, we don't want to leave anything open to interpretation. We don't want to, whenever you're communicating anything with anyone in your design or in your discussion, even if you're just writing an email to somebody, or if you're trying to explain how something works, always think about what they need to know to fill the gaps. Imagine the gaps that they may have in their mind. So never leave anything open for interpretation, in that they may be kind of guessing like, what does this person mean? Do they mean this or that? Yeah. Okay, let's move on. So we know that we got this component specifications, and let's take a look at this. Okay, so we get a bidirectional motor. We already know that. And then we also know that we're going to linear actuator that moves the tray. So the tray is going to go out. You guys already know that. Now, this is the one thing that's important. Must be single cylinder spring return. Okay, so that's just, you know what, I'm just going to start with that. I'm just going to go get a single cylinder spring return, throw it in there, because that's the first thing that it tells me. That's the only thing that it says you must use this. Actually, there are a few other must use this things. I think I'll focus on those. Third linear actuator, okay, so that's going to come down. And the compressor, receiver, no, I'm not even thinking about that. Not even going to think about that. So let's move on. The ink storing mechanism. Okay, so the motor is controlled by 2 push-button valves. You know what? I'm going to definitely throw 2 push-button valves in, because it says that. This is the first thing I'm going to do. So, and then we've got this whole operation here. So let's go visit this again as we're doing the control. As I look down over here, these are all the specifications. This is stuff you're going to be calculating. This is stuff you're going to be like putting in your report. This is stuff you can label later in your build, in your circuit diagram. So you should be labeling certainly whatever pressure you're setting the regulators to. There are 2 regulators, this one and this one. You should be labeling them. But right now, don't worry about that. This is all about the technical specifications of what size cylinder and what pressure. I don't care about that. I just care about the full operation here. Now, we know there's this idea here of this 2-hand safety control. It's complicated. You know what? If you can't add it in, don't worry about it. I'm not going to give you the answer for this, but I'll give you some hints. But this is something you can do completely later. Okay, don't even think about it right now. So we'll visit this later, but right now we're just going to focus on building the circuit. So I've started with a student's project. I've grabbed one of your projects. And what I'm going to do is I'm just going to modify it and change it around a bit, because it's already got these components. So I'm going to grab this guy. I'm going to get rid of that stuff. Get rid of this for now. Yeah, put that in later, whatever. Now, I want to show you guys something. I'm going to come over here to the project description. So, for the project. So when we go into the main project area here, we got video help. If you go down here, it shows you all the way, shows you how to resize the work area. So I'm just going to do that right now. I'm going to right click here, and I'm going to go to document properties, and then I'm going to go to the size. So right now I'm going to click on this, and I'm going to go for like 11 by 17. It's a pretty big sheet of paper. Okay, good. So now it is that size, and yep. And we can see, look at all this extra room I have here. So this is great. I have a lot of room to like move stuff around. Now what I need to do is I need to think about which components I need here. Essentially, I'm definitely going to have a double acting cylinder. I'm going to have this. I've already got some metering. I'm going to maybe take that out for now because I said I don't really want to think about it right now. Oops, I didn't mean to do that. So I've got limit switches. I've got everything here. So I'm going to rip this apart, and I'm going to move some stuff around. I'm going to get rid of the stuff I don't need, and then we'll start from there. So this guy is associated with this guy. So what I'm going to do is I'm going to click on this, and I'm going to call it my stamp because I want to change that to stamp. So solenoid capital S plus, good. And then I may or may not, you know, I'm just going to start with, because the parameters don't tell me whether or not I need a spring return or not. I'm going to turn this guy into a solenoid. How come I can't do this? Technical specification. There you go. Now I'm going to click on this guy, and I'm going to make that a solenoid. Okay, good. Now I'm going to have to name that, and I'm going to have to do that through ladder logic. So I'm going to pull another one out. So I'm going to say this guy's associated with this. That's sort of associated with this. So I don't have another solenoid here, so I'm just going to grab one. I've renamed that this. I've got this guy here and that guy there. So I've got these guys. I'm going to rename these guys here because this is supposed to be tray, because I've just changed that to tray. So I'm going to click on that. I'm going to rename it. This may or may not be quicker for you than just designing it and just doing it all, but I mean, I've already done the work here, so I just have this. Now, this automatically got renamed. Now I got limit switches in here. So let's, I think, go with this because we got a bunch of stuff here. Now, what do I need to do is I need to add a cylinder. It was actually the first thing I wanted to do. So I'm going to go up to pneumatics, and I'm going to go down here to actuators. There we go. I got a spring return. I got that. Now, when we're doing this, we definitely need to have a 3.2 DCV. That's what I want. Good. So I'm going to name that guy. I'm just going to put this right up here. And I'm going to name this, but I need a solenoid for it. So I'm going to bring one in, and I'm going to name that solenoid, and this is my clamp plus. Okay, good. Now I'm going to grab this guy, and I'm going to associate him with the clamp. Elemental solenoid clamp plus. Perfect. Good. So now I've got all of this stuff. It didn't work. I'll do that again. So now I can start building my ladder, although I'm probably going to need some limit switches here. Also, I need to label this. So I'm just going to copy this and paste it. I'm just going to put it over here, and I'm going to rename this. Now I got this. Right, I need some limit switches here. So I'm going to go over and grab some limit switches. You know what? And this clamp here, I'm definitely not going to be able to use a mechanical limit switch for its outermost action, right? So when it fully extends, I'm not going to be able to use a mechanical switch there because it's a clamping operation. So I'm definitely going to be using a reed switch there. So let's go get one. I'm going to have to guess where it goes, but I'm just going to guess maybe somewhere out here. There we go. We can align that. So let's click on this guy and align this. Nice. So I've got my limit switches. I think I can start with my ladder logic now. I don't have to worry about metering or anything. I'm just going to go here and here. I just want to design the very, very basics of control. Now, I'm not going to go back to the project description because I know that how it's supposed to work is that an operator puts both hands down. I'm just going to use one hand for now, and then I'll put the two hands in later. And I know that the first thing that happens is the tray extends, and then the next thing that happens is the clamp extends, and the next thing that happens is the stamp comes down, and then the stamp retracts, and then the clamp retracts, and the tray retracts. The way I know that is because when you're doing your preliminary design, I would imagine the first thing you did was on paper, just draw the cylinders and the DCBs, and then think about how you need to control it. So you already know how the actions are supposed to happen. Again, we're not thinking about the timing or any of the extra stuff. We're just going for the basics. Let's try and build a ladder logic. Okay, so let's talk about ladder design. So what I've done is I've done some basic designing here. And just let me show you what's going on. One thing, I'm only using one start button. That's it. I don't want to do the two hands right now. I'll think about that later. It's too much to press stuff to test it. I just one start button. Now, I've just latched on to the information. So the start button is going to energize this, and that's going to close this, and I'm going to hold on to that. The reason is that I'm doing that is because I know I'll need this information probably in two different places. I don't want to latch onto it. Okay, so and I've built a holding circuit here. I'm going to need a termination contact at some point, but I'm going to put that in later. I'll think about when it comes. Okay, so what I've got is the basic actions. The operator presses the start button, the tray goes out, the clamp extends, the clamp stays extended, the stamp comes down, the stamp is going to come down, and then there's a timer. I'll do that later, and then it retracts. And then the clamp retracts, and then the tray retracts. That's all I want to do. That's it. So let's focus on that. Now, there's conflict here. Actually, let's talk about the conflict. As long as, if I say to the stamp, okay, as soon as you extend, I want you to retract. Typically, we have conflict where there's an action like A plus and then A minus right away. Or in this case, it's S plus and then S minus right away. And that's a problem because I've got the clamp. When the clamp extends, it tells the cylinder, the stamping cylinder, to go out. So as long as the clamp is extended, it's always telling the stamp cylinder to extend. But that's a problem because the event, when I'm doing event programming, the event that makes the stamp retract is the fact that the stamp extended. But the stamp is being told to extend because the clamp is extended. So I have to do something about that. We get rid of conflict with holding circuits. And I'll show you how that's done. But right now, let's analyze this circuit, see how it goes. So what I've done is I've taken all my outputs and put them down here, all my inputs down here, and I've built this. Simple. I've also added a couple limit switches that I didn't have when I kind of put this together. And let's just go on and take a look at this. So what I've got is I'm going to press play. That's going to energize this. As soon as this closes, my T plus is going to come on and this will extend. Okay, that makes sense. When this gets hit, I want the clamp to extend. Okay, so when T plus LST plus gets hit, I want this to energize, which is a clamp. And by the way, this should probably be labeled TS and then LS lowercase t, because we named the limit switches with lower cases. But moving on. So my clamp extends, and when the clamp fully extends, right? When the clamp fully extends here, I get this information, and it extends the solenoid. Extends the stamp. And then when the stamp extends, it's going to retract the stamp. But the problem is this is telling this guy is telling this guy to stay energized. So I'm going to have to shh. I'm going to have to tell this thing to shut up, right? So that can't make any action happen because this is still happening. So I'm going to have to tell this thing to shut up. I don't want to listen to it anymore. And then what I'm going to do is once the stamp is extended, and then once it's retracted, I'm going to take this information. And the way I'm going to retract this guy, how do I retract this? I just turn this off. So as opposed to me taking this, the stamp is retracted, and then energizing, say, a solenoid over here, I have to de-energize this. So I'm hooking it up to a relay, and then I'm going to put a normally closed there. So the clamp I'm just turning off. Okay, let's run this, and we'll see that there's conflict. I'm just going to zoom out a little bit here. Okay, here we go. So I've written the control statement up here. Let's take a look at it. We've got conflict in here, s plus, s minus for sure. But the other thing is that we've got t plus, t minus. There's actually conflict there too, because we can look at those actions happening right after another. Even though they're on either sides, there's still kind of a loop going on. And we'll see what happens. Watch this. When I press play here, I do that momentarily. This energizes. Okay, my T plus is energized. Why isn't the cylinder going out? Because look down here. The clamp is retracted. I have a piece of information that says when the clamp retracts, when the clamp retracts. I shouldn't be thinking if the clamp is retracted. I have to say when the clamp retracts, then I should retract the tray. So what does that mean? Well, I have to not just say if it's retracted, but when it was retracted. So what does it mean? What's the difference between if it is retracted and when it was retracted? Or when it retracts? Well, the thing is, when it retracts, that's an action as opposed to a state of being. So how do I put in here the action of it retracting once it retracts? Well, I have to essentially say that it was extended. Oh, was logic. Oh yeah, it was extended and now it is retracted. So let's just do that because look, it's just not going to work. So I'm just going to add that in right away. Again, this is conflict. I'm going to resolve the conflict with the holding circuit, and essentially that's was logic. So this is the piece of information I need to hold on to. I need to hold on to this. Now, at no point do I want to hold on directly to any of these signals. Not at all. So what I'm going to do is I'm going to take this guy. I'm just going to move him out of the way. I'm going to put a relay there. I just want to put a relay directly on there. Actually, the best thing to do is just put a relay on every single limit switch. Then if you need to remember a limit switch hit something, you're not latching that limit switch down because you might need to know that information. You might need to remember the fact that it was closed, and then you have to say now it is open. In other words, you have to read it twice. If I latch onto it, put a holding circuit directly around this and it opens, I won't know. So I'm going to just tie this to a relay. I'm going to grab a relay and put it in here. Now what I've done is I've tied this directly to a relay. So it can open and close as long as I'm not latching onto this and remembering it. If it opens, I'll have that information. I'm taking this contact R4 and now this information is relayed to this contact through R4. Now I can do something with this. And actually what I'm going to do is I'm going to tie that into a holding circuit. Again, a holding circuit. So I'm going to just put a relay here and call it R5. Now I've taken this information here and I'm holding on to it. So I can say, if this is closed, if I talk to R5 and I can say, hey R5, is the clamp extended? It'll say, I don't know if it is extended, but it was extended. It happened at some point. So now I have a piece of logic down here that doesn't say specifically if the clamp is retracted. It'll say if the clamp is retracted and it was extended. I'm going to put this into R5. That's why I taught you guys was logic. Okay, good. Now I've got a situation here where the only time this will be energized is if the clamp was extended and now it is retracted. Now, what about this guy? What do I do with this? You know what? I'm not worried about it. I just want to get the first thing going. This was conflict here. We resolved it through this idea of holding circuit and the idea of was logic. I'm not saying that I want this solenoid to energize when the clamp is at home, but when it gets home. And that's what this is. When it was extended and now it is retracted. Let's run this. And I don't think there'll be a conflict. We'll see. This will extend. There's probably some other stuff that won't happen, but here we go. Good. It extends. Good. So now what we have is, for some reason, the clamp is not extending. And that's because R3 is energized. Wow. Okay. So once we get over this conflict, and we resolve just the actions, then we can add the stuff. So how do I resolve this? What's going on here? Well, the thing is, I need to quiet this. I don't want this to happen. Think about this. When do I want the information that the stamp has retracted? When do I want that information? Well, I want it after the stamp has extended. So again, I'm going to put a holding circuit onto the extension of the stamp, and then I'm going to allow this to happen. Same thing we did here. Same thing. In this case, I said, When the clamp extends, I'm going to listen to the limit switch that is the clamp retracted. Same thing here. I'm not going to listen to the limit switch that says the stamp is retracted until it is extended. So let's add that was logic there. Okay, let's take a look at this. I've got my LS plus and I've tied it to my R6. So anytime any contact from R6 closes, that means the stamp limit switch is closed. That means the stamp is extended. Remember, I'm saying is, not was, is extended. Now, I've got a piece of information in R7 that says it was extended. So if I were to ask R7, hey, is the clamp extended or not? It'll be like, I don't know if it is, but I know that it was, because it's remembering that it was. Now I'm going to take that information and I'm going to put that onto my S minus, because I don't want to know the information about the clamp retracted until it has retracted. So I'm just going to, I'm going to tell it to shut up. I'm not listening to you until I don't want to know the stamp has retracted or is retracted unless it has extended. Let's go on there. So again, it's just was logic. So I'm going to put a contact from R7 here. So now if I do this, I've removed 2 bits of conflict. There's one more piece of conflict that we can resolve. Okay, watch this. Okay, bear with me. Let's go over this idea of this conflict that I think we've resolved so far. We had 2 pieces of conflict. One is the tray wouldn't extend and the other is the clamp wouldn't extend. The reason the tray wouldn't extend is because this solenoid, the solenoid to make it retract, was energized. The reason that was energized is because if we go down here, the clamp was retracted. So we had a piece of logic here that says if the clamp is retracted, turn this on, turn that on. But we got rid of that. And we said if the clamp is extended, and I'm remembering that it's extended, and I'm taking that memory and I'm putting it down here, this says the clamp was extended and now it is retracted. So the only time this is going to come on is if the clamp extended and then retracted. We have the same situation here with the clamping cylinder. The problem exists with the clamping cylinder. The clamping cylinder, we want it to extend when the tray extends. Here's the command here. When the tray extends, then turn the solenoid on to extend the clamp. But the problem is, this is open. That essentially is the command to tell the clamp to retract. Now, why is this energized? Well, if we go down here, my R3 comes from LS, the inside LS limit switch. Again, we have a piece of conflict that says, if the stamp is retracted, then retract the clamp. Well, I don't want that information. I want to say, if the stamp was extended, there's the stamp. The stamp, if the stamp was extended, remember that it was extended. Put that information here. So now R3, you can just look at R3 as essentially, R3 is just a solenoid that retracts the stamp, right? Because this comes up here and it terminates this, and this de-energizes, and this de-energizes, and the spring takes over, and this spring takes, and it retracts. So we can look at this as though it's a solenoid to retract the clamp. We had a piece of information here that said, if the stamp is at home, retract the clamp. Well, no, I want to say if the stamp was extended, again, I've got if the stamp was extended, R7 is down here. This says if the stamp was extended and it is retracted, then retract, in this situation, it says retract the clamp. So this is not energized. It's not activated, therefore it's not open. So let's try this. That extends, so we just removed 2 pieces of conflict. Now, why is the stamp not extending? Well, because I moved these all over here. So where do I put these back? When do I want the stamp to extend? Where's my clamp? Okay, there. When my clamp extends, I want to energize this. Okay, well, that's easy. I can just put this in here. I can put this right here and directly connect it to here. Let's do that. Okay, let's run it. Nice. Good. Now, when do I want this to retract? Well, we've got conflict again. Again, this is the whole idea of the stamp extending and retracting. So we've got conflict. So how do I resolve that? How do I remove that conflict? Well, first thing I do is have to look at where it's coming from. It's actually coming from this guy here. So when the clamp extends, this limit switch tells this guy to energize. And then this extends. But the thing is, the clamp is still extended. So it's continually telling this thing to extend. So I either have to turn this off, just shh, quiet, or I have to turn this off. I have to tell this to shut up, I'm not listening to you anymore, or I have to turn this off. So let's investigate the two options. One is I can turn this off. So let's go to it. So clamp plus, and that's going to be here. Now I'm actually using this over here. I got my R4 over here, and then I'm holding on to this. So if I turn this thing off, I could do that. But the other option is to actually just quiet this thing, to turn this thing off. And actually, you know what? I don't want to mess with limit switches. I don't want to tell them to be quiet. I don't want to say, no, stop it. Because what if I need that limit switch somewhere else, some other time? So my choice is going to be to turn solenoid plus the stamp plus off. I'm going to turn this off. And I'm just going to put a contact in here. It's going to be a normally closed contact. Now, when do I need to turn it off? Well, when it extends. So I'm going to take the information from here, and I'm going to create a contact here that opens. Now, let's take a look at this. I've already got a holding circuit on this. So I can take an R7 and just put a normally closed here, and it will retract. Not only will it retract, but because R7 is a holding circuit, it will remember, and it will tell it to fully retract. Now, before I do that, I'm just going to say, you know what? I got to put a timer in here anyway, because this thing has to extend. It's supposed to extend and stay extended for a certain amount of time and then retract. So when it goes out, that's when I start counting. You know what? I'm going to put a timer right in here, in this holding circuit down here, and then I'm going to put a contact from the timer here. Okay, let's do that. I'm going to grab a normally closed timer contact, and I'm going to stick it in there. Okay, let's run it. So we're going to go out. We know there's no conflict with this, and wait a certain amount of time. This opens up. Oh, so what's going on here is that I've turned this off, but I forgot to turn this on. Oh yeah. So that's fine. I can just grab another contact from the timer, in this case a normally open contact, and energize this. So solenoid S minus is right here. I got to put that in the rung somewhere. Okay, good. All right, so I've got rid of the conflict here. It turns this thing off, and then this will close and turn that on. Let's give it a whirl. So that extends, this. Okay, the timer comes on. When this closes, nice, it retracts. Nice. Now I have to get this. Oh, the clamp needs to retract. It already did retract. Why? Let's watch that again. Okay, so that happened. Sorry, that. Let's go. Okay, that happened. Oh, I've probably got some conflict in here that's locked in. Let's just try this again. Okay, this goes out, this goes. Why does this retract? Why does C plus de-energize? Why does C plus de-energize? C plus de-energizes when this opens. R3 energizes. R3 energizes when limit switch. Oh, right. The stamp, when it gets back, that's the inside limit switch for the stamp. It's over here. It tells this to energize. It tells this to then become open. And it turns this off and this retracts. Okay, good. All I have to do now is get this to retract. Now, the clamp, remember how I was talking about how there was conflict between S plus and S minus? There's also conflict between T plus and T minus. And we saw that in the very beginning. But there's still conflict there. So how do I get this to retract? Once we do that, then we'll have the whole thing, all of the actions happening. Plus I have a timer in there. By the way, I'm going to change that timer. Let's just do that now. Good, that's set to 7 seconds now. Okay, so now what I need to do is retract this. So I have to energize T minus. When the clamp goes home, that should energize. Now, but the problem is T plus is still energized. So this is still energized. So to solve this conflict, I'm going to think about event programming. My thought here is that when do I want the tray cylinder to retract? When do I want this thing to retract? Well, when it extends, but after the 7 seconds. So I'm going to take the event of the 7 seconds being done and use that event to, 1, tell the solenoid to retract, tell the solenoid T minus to retract, but I'm also going to quiet T plus. So all I'm going to do is put a timer up here, and this rung up here, I'm just going to put a normally closed contact. That'll get it home. Now, when it gets home, we're going to be kind of stuck with some holding circuits here. We're going to be a holding circuit here, and a holding circuit here, and a holding circuit there. We have to think about when that's going to shut down. We'll tackle that in a second. So let me just put a contact up here. So let's try this. I'm going to run this and see how it works. Start, the tray goes out, the clamp, then the stamp, and then 7 seconds later the stamp retracts. Once it retracts, the clamp is going to retract, and then the tray should retract. Nice, the tray. Okay, that's it, we're done. Now, if I press start again, what happens? Well, nothing. The thing is, we've got a bunch of holding circuits here, so I need an event to shut down this whole thing because it's done. What I'm going to do is I'm going to think about what event is going to shut it down. Well, the event is that, well, when the tray retracts. So can I take the information from the tray retracting, if I could take that and say, if this gets hit, if it gets hit, then shut everything down. Well, I can't say that because the problem is when I start, this is hit. So I have to say, I have to use some was logic. I have to say, if it was extended, if the cylinder was extended and it is retracted, then shut this off. So what I'm going to do is I'm going to see if I've latched on to this information and remembered it. And actually I have. If you look down here, I'm taking this guy here. Actually, no, I haven't even done that. All I need is any other event that's remembering the tray wasn't at home. So it's kind of like this. If the tray wasn't at home and the tray is at home, then shut everything down. So what do I have here that tells me the tray wasn't at home? Well, I got a holding circuit here and a holding circuit here. I can actually use either one of these. This guy here indicates that the clamp was extended. Well, the clamp only extends if the tray extends. So yeah, we can say if the clamp was extended and the tray is retracted, then shut everything down. So I'm just going to take that. I'm going to take this information, R5, and I'm going to make a new rung. Okay, let's do that. Okay, we're almost done. Okay, we're almost done just the basics. Now let's take a look at this. I've got a piece of information here that's it's all about was logic. It says if the clamp, right, this R5 will energize if the clamp is extended. And we get that from here. So this R4 is driven by the clamp extending. So when this closes, this will close, R4 will energize, this will energize, and now we're remembering that the clamp was extended. Now, we have another piece of statement here that says, if the clamp was extended and the tray is retracted, then turn on R8. Now, R8, we can put a normally closed contact up here and terminate this guy. Let's just do that. Okay, I have this up here. Let's take a run, and we'll see what happens. Now, there's still some other holding circuits that we have to deal with because I've got a holding circuit here and a holding circuit here, and both of them have to be terminated. Well, my question is, when do I want to terminate them? Well, when it's done, when everything's retracted. Actually, right now. We want to terminate them right now. See, this guy has opened because the logic of this rung here happened and it shut this down. What we're going to do is we're going to take an R2 and we're going to put it here and here, just to normally open. Because this will allow this to work. As long as I've pressed the start button, this rung will be allowed to work and this rung will be allowed to work. And when everything retracts, this holding circuit's going to die and it's going to kill these holding circuits. Okay, let's do that. I think this is going to work now. Let's give it a whirl. So extend. Okay, the timer goes on. It's counting. When the timer, that's going to close, and that's going to close, and this is going to open. Good, and that retracts. Now everything, you see that? Everything gets shut down. So what we have now is we have the whole operation. All you have to do now is add some extra stuff. Okay, you've got to add another timer for sure. You've got to add another timer because there's a timer on the clamp. Plus, you've got to add the two hands shutdown. I would also put a normally closed contact here, a stop button, right? So you're going to stick a stop button in there just because you want to be able to manually stop. And then you've got more pneumatics stuff to go on here. So you've got to think about whether you put metering in these things or whether you're going to have cushioning in these things. Now, let's tackle the idea of putting a compressor in here and also putting some other stuff. Now, let's tackle a few other things. What I want to say is the stamp in this case. What I want to do is I want to put the stamp so it goes down. So I'm going to have to rotate this whole thing. So here's my compressor. I'm going to grab a compressor and I'm going to put it in here right now. I actually want a little bit more space. I just want to put this here because I think I'm going to stick my compressor in the corner here. Can move it all over later. Now I need a tank. Now the problem with the tank, if I go for a reservoir, pneumatics in Automation Studio is a little bit weird. So I'm just going to use an accumulator. So I'm going to use, I'm just going to use this gas loaded accumulator. I'm going to bring it over here. I'm going to flip it over actually. Because typically we draw the tank underneath. So what I've got is I've got my pump directly connected to there. Now I want to put a pressure regulator on there. You're going to need 2 pressure regulators. One for your stirring mechanism. And you know what? I'm not going to draw that because you guys can handle that. You know how to do that. It's easy, but it needs to run on 40 psi. So it needs its own pressure regulator. So you're going to have 2 pressure regulators. I'm going to go over to pressure reducing valves. I know it's kind of a bit of a weird name, but that's what it's called. And we want a variable one. So I'm going to bring this in here and I'm just going to put this here. I'm going to stick it right after this guy and I'm going to connect it in here. Okay, so now what's going to happen is when I press play here and I start everything, this guy's going to start to go. It's going to start to fill this accumulator. And you can tell that this is blue. This is blue right now, and it's taking a while to fill this. I can do 2 things. One is I can change the specs on the motor to speed it up, the RPM, or even the size of the motor. And I can also change the specs of the accumulator. What I'm going to do is I'm going to change the specs of the accumulator. Clicking on the accumulator. I'm just going to go down here to volume. I'm going to turn this into liters. And I'm just going to make it a 2 liter. That's nice and small. Okay, good. Now, when we run it, we can see it'll fill pretty quickly. This blue, there, it's red now. So now this guy is set to 5 bars. I want to put that in PSI. My maximum pressure is in bar. I'm just going to go for PSI. It's pretty high right now, but what I want to do is I want to just do the setting. So it says setting for the pressure. Again, that's going to be in PSI. And I'm going to, 72 looks good because I don't know what pressures you guys are using. So let's go with this. Actually, we can go for, it's set to 72. It can crank up all the way up to 507. So that's a little bit ridiculous. Let's just put this at like 120. And the other is that I want to click on this to show the actual pressure. Now watch this. Okay, right now that's the pressure setting. And let's run this. Okay. So the pressure setting 75, but the pressure isn't specifically 75. We should put a gauge on there. I'm going to go down to sensors and other, and I'm going to grab this guy, and I'm just going to stick it right there. I'm going to double click on this thing, and then I'm going to set the pressures to PSI, and I'm going to go down here to PSI. And because this is clicked, it will show the pressure. Okay, let's do this. As we go here, it's going to run up. Okay, we're going to watch it increase now. Now, look what's going on here. We know that this regulator is set 72 psi, but why is this going up? It keeps going up and 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 up. Now, we don't have a control system on here to shut this down. We haven't studied how to do that with compressors yet. So we're just going to leave this. We're going to leave it at a ridiculously high pressure. But the thing is, and it's okay, Automation Studio won't blow up. The thing is, the output here is actually still on 72.5 psi. Let's check that out. I'm going to put a pressure gauge here, and let's watch to see what this gauge says. And let's give it a whirl. You'll see that the pressure on the outside never goes past 72.5 psi, but the pressure in the tank, which this is showing, goes up and up and up and up. So the pressure, I can take this pressure and run it to everything else. Let's run this now. This pressure should continue. Nice, it's going up and up and up, and then these lines become red, and everything's pressurized. Good. So now when I run this thing, it's going to run. Let's just do a test. Good. Seems to be running. So I put my compressor in here. I definitely put some pressure gauges in here. Now you have to put another regulator in to run your motor, to run the pneumatic motor. And remember, that DCV is going to be controlled with limit valves, not push button switches. Again, the other thing is that I want to definitely put a stop in here. Now you've got your logic that you've got to put in here for the automatic stop, right? If the operator puts both hands off. Now the other is in that operation, when the operator takes both hands off, what's going to happen is that the tray cylinder will stop in the middle of its stroke. Wherever it is, even if it's in the middle, it'll stop. You need a special DCV for that. This guy, the stamping cylinder, will also stop, but the clamp will stay extended. You have to think about how to do that. It's not easy to do that logically here in the ladder logic, but give it a whirl. I mean, it's actually not that difficult. You can handle it. Now, the other is that you have to make sure that if this is gonna stop in the middle, you need a different DCV here and you need a different DCV here. If you're gonna change those, you probably have to modify your ladder logic just a little bit. You know, I didn't even think about the fact that I'd be pretty much giving you everything you need. Yeah. So, I mean, you still have some stuff to do. You still have some things to add. You still have to clean it up, make it look pretty. Think about safety. Maybe think about, like, you know, something holding against gravity, something like that. Yeah, we studied that in lecture. Add some safety, clean it up, put in any other components you want. If you want to use a pneumatic timer instead of an electronic timer, that's fine. There's no parameters that says you can't. So I'm just going to let you go with it and just roll with it and just get her done. And that's all I have to say. Everybody.